Okay, I guess now is a good time. Thank you, everybody, for tuning in this afternoon. I know it's a 2 p.m. start if you're in the Eastern time zone, and this is usually when you folks have your peak productivity period. So I'll try to make this as productive as possible for us. What we'll be talking about today is a guide to modern AI strategy, and I like to label it as thinking into the future, because what we'll be focusing on today is much different than most new comp webinars. We'll be focusing more on the strategic side of things. We'll be focusing more on how to think about approaching AI rather than actually seeing a demo of a tool or talking about the technical nitty gritty like the architectures and so on. So what I'd like to do is I'd like to just really quickly set out some ground rules or some housekeeping items. First things first, there is a Q&A box. If throughout the talk there's questions that you may have, feel free to send them in. I will allow some time at the very end of the webinar to answer some of those questions. We have kind of planned this to have at least about 10 minutes at the end for some questions. So feel free to pop them in as you see fit. There will be time at the end for your questions. Unfortunately, this is a webinar, so it is a one-way street. There's really no other way for interacting or chatting other than watching the slides in the Q&A box. But if you do have anything, feel free to email me. My contact info should be on the right-hand side there, or you can book a meeting with me and we can discuss this. This talk is not industry specific. I will try to touch on as many industries as I possibly can. One of the rationale and the reasons behind this talk is because there's a lot of individuals who have approached me and essentially asked, how do we get started in AI? How do we convert what we're doing in data science and analytics? How do we move that into the AI world? And I thought it'd be a really interesting time to essentially just put some of those thoughts together and essentially start thinking about the future. So I hope you find it insightful. I hope that you find it, at least inspiring to the work that you'll be doing, at least when you start your next planning cycle around your data analytics and AI strategy. So with that being said, I'll give you a little introduction to myself. So my name is Piero Dimitri. I am the practice lead currently for strategy and AI here at New Comp Analytics. I've been in the consulting world for over 7 years, and I've been in the data and analytics world for 10 years. When I started doing what we now call data and analytics or data science, it was called scientific computing. And essentially it was done in the university lab, and you took lab data and all your findings and your data you collected, and then you would create an algorithm and then sort of model that. My first model that I've ever created is around the planetary motions of exoplanets around a star. And to say that much has changed since then would be a lie. A lot of the techniques are pretty much the same. The only thing that changes is I don't study stars and planets anymore. I study businesses, dollars, and profits, essentially. So same techniques, but essentially different context. I have had my fair share of experience with consulting. I did work at PwC for a bit. I was at BDO before rejoining New Comp Analytics. I also do manage to teach at some of the universities around the Toronto area. I do teach at the School of Continuing Studies at University of Toronto, where I deliver the Data and Analytics Coding Boot Camp. I also deliver a seminar at the Queen Smith School of Business about Python and its various uses. And then lately, I've also been facilitating a data visualization course at Ontario Tech, formerly known as UOIT, just to get their tech talent program up and running. Outside of work, whenever I do have time, I am a private pilot, so I do enjoy just flying and going across Ontario into small little towns and figuring out what charm all the little towns across Ontario have. I do have a little husky, although he's big now, who does keep me busy at least 2 hours a day on walks. And occasionally I like to listen to music on weekends and play around with some DJ equipment downstairs. So just a little bit about me. I have spent, like I said, a majority of my career in data and analytics, and now I'm stepping into that AI role as I see it kind of becoming more mainstream into the business world rather than just academia. A little bit about NewComp. I promise not to spend too much time on this, but NewComp is a boutique analytics firm centered here in Toronto. We do work all across North America, including the Caribbean. We have analytics clients in all industries, and we are partners with some of the biggest vendors, specifically IBM, Microsoft, Alteryx, Tableau. These are all vendors that are leading the charge in the data and analytics world. But at the same time, they're also vendors that we would like to endorse and promote when we do go out to our clients. So it's a very, very busy world out there when it comes to tools and technologies. And I'd like to think we've selected some of the better ones, and we work with some of the better vendors out there. So it is a broad landscape, but there are a lot of good vendors out there. We do have advisory services, much like the strategy discussion that we're talking about today, but we also do development. So we do put our money as where our mouth is, per se, and we walk the talk, and we do implement those solutions that we do suggest, whether it be in architecture or in strategy. So we do have the advisory side, and we also have the development side of the house. There's a couple of topics I'd like to talk about, but my main focus is AI and machine learning. We do have folks at NewComp who focus their time on data engineering. We have other folks who focus their time on BI and data visualization. We have a very thriving FP&A, or financial planning and analytics practice, that focuses on strategic corporate performance management and financial planning. And all that wouldn't be possible without having a strong foundation in cloud concepts. So we do work with a few cloud vendors. We do have a strong foundation in cloud. So overall, our focus is strictly on data and analytics and AI, but we do have some of the supporting components that go around there as well. So enough about me and NewComp. I'd like to get to the key points of what we're going to be talking about today. And this is going to be a very open-ended discussion, a very light touch discussion. There's going to be 4 key points that I'd like to drive across. The first one is AI is not ML, and ML is not AI. One of the things that I've been trying very, very hard to do since I decided to go out to businesses with my knowledge on AI and ML is try to get everybody to speak the same language. And there's a lot of buzzwords in the industry today. Specifically AI, artificial intelligence, machine learning, deep learning, neural network, data science. And the thing is, there's really no unified definition, or really no standardized definition as to what each of those mean. So what I'd like to do as the first matter of our webinar today is I'd like to define what each of those mean. And I'd like to focus our time on getting those definitions correct, and ultimately making sure that when I say AI, you guys know what I'm talking about. When I say ML, you know what I'm talking about. When I say deep learning, you know what I'm talking about. And when I ultimately say neural network, reinforcement learning, things like that, that you know what I'm talking about. So I'd like to spend some time on demystifying some of the buzzwords, and then ultimately going a level deeper and trying to figure out what each of those really mean. And then from there, I'd like to move over to what I call analytics versus AI. A lot of folks believe that AI is growing out of analytics, and while that is very, very true in a lot of organizations, I actually firmly believe that AI will be broader and bigger than analytics is currently. Analytics is currently a tool in helping businesses make strong and good and effective decisions. And AI is also a tool that can help make strong, effective, and good decisions. It's just the approach for those two is slightly different. We'll talk about that when I talk about analytics versus AI. After we've done some of that level setting, we've defined the definitions, We know where AI and analytics are different. What I'd like to do is I'd like to spend a little time on guiding principles. So there's a lot of knowledge out there. There's a big body of knowledge on where do I start if I wanted to adopt AI and analytics, and where do I go from there. What I, based on my experience with some of the successful adoptions that we've had, there's a few key things to keep in mind, and those are the things that ultimately make sure that there's a successful rollout to the AI strategy within an organization. We'll talk about some of the key guiding principles there. Of course, it's not an exhaustive list, but these are some of the things that I think at a high level are going to be important, and these are the things that ultimately should drive the adoption of AI throughout the organization. Finally, what I'd like to do after we've talked about some guiding principles, in those guiding principles, there's going to be some use cases that will naturally flow out of that. I'd like to focus on 5 of those key use cases. These 5 use cases that we've identified have had successful rollouts. Majority of them are in operations in our client sites, and they are, believe it or not, successful in their goal. So we'll talk about what those 5 use cases are. What are the algorithms that pin those 5 use cases? And then ultimately, why are they so successful? What makes them so successful? And then trying to understand how we can replicate that success using those 5 use cases within your business or within your specific context. So ideally, like to start at the top, set some definitions down, make sure that everybody's on the same page, talk about how AI and analytics differ, but how they're also the same. Then from there, moving on to what are our guiding principles for building AI. So we're going to essentially abandon analytics and abandon the analytics world for a second and move into this AI world. And then ultimately, where to start in the AI world. What are those 5 use cases that have been successful that we can try to replicate over and over as a starting point so that we can actually have a little more success with that. Like I said, it will not be industry specific. So if there are any specific use cases you'd like me to touch on, please use the Q&A box and I'll try to kind of give my experiences when it comes to specific industries. Okay, moving on. Our first key point is that AI is not ML and ML is not AI. I'd like to start with a little history lesson. I'm sure most of you have kind of heard this speech, but NVIDIA was one of the first real hardware providers to jump knee deep into AI. And essentially, they wanted to be the first to kind of set the playing field, essentially, when it came to terminology, when it came to technology, when it came to that. So they've done a really good job of setting those definitions, of making sure that everybody understands what each of those terms are. So what I'd like to do is I'd like to make sure that everybody is aware of it, but at the same time that everybody is using the same language, so that when we say AI, we know what it means. When we say ML, we know what it means. I'd like to start this little history lesson back in the 1970s. Artificial intelligence has been around since the 1970s, and that may be a shock to some of you, but it's actually very, very true. Early in the 1970s, there's a group of scientists who got together and decided that we can actually use these calculators, these early stage computers, to actually help us in our decision making. And one of those early use cases is, of course, as you know, a calculator. But ultimately, all of these little punch card machines and all these other things, they ultimately help and augmented the human capabilities in terms of decision making. So, to no surprise, we've had what we call AI since the 1970s, and all that meant is trying to replicate human intelligence and human decision making into these synthetic machines, into these machines that could take a task and try to replicate it and then output a decision, a very binary decision at the start. And we did a really, really, really good job of that. And, with the adoption over time, we've seen the introduction of the personal computer. We've seen the introduction of cloud, of these centralized services, as I like to call them. And then we've also seen a lot of applications throughout business, a lot of applications throughout our personal lives evolve as the computing world evolved. And essentially, all they do is they help us make these decisions. So at the end of the day, AI has always been about making good, effective, strong decisions. Now, up until the very early 2000s, 2010s, it was very what I'd like to call deterministic in nature. So, deterministic in nature, partially because a computer took a scenario, determined whether it was true or false, and then output a decision based on that. So, in those cases, you have if statements. If you're familiar with coding, there's a lot of ways to do if statements. You got the if, else. You also have case when something, do this, and then if not, then do that. So those scenarios where a computer could easily evaluate if something is true or not, and then output a decision based on a specific case. Well, those are very important because it is a computer making a decision, but it's a decision based on rules. So we'd like to call that rule-based intelligence. And the rule-based intelligence is very, very deterministic. It's very 0 or 1, and it doesn't allow for anything in between. It doesn't really allow for maybe true or somewhat true. It really has to be, is this true or is this false? And what we've done now, because of this rise of computing power, storage capabilities, and the lowering of the general cost of computing and processing, we've now been able to not only collect more data, but at the same time, we're being able to use and process all of that data that we collect in a time scale that makes it actually efficient and effective. And with that, what we've seen is this rise of machine learning. And the rise of machine learning has given us the ability to make probabilistic decisions. So not binary decisions like 0 or 1, but something in between. Something like 0.75. How many times am I going to see this scenario play out? 75% of the time. Or things like elections, where we have 9 out of 10 times, this person will win the election. So it allows us to make more probabilistic decisions because we have a broader foundation that we have now enabled because of these low costs and these technologies that have come about. And machine learning is part of artificial intelligence, but it is not all artificial intelligence. Remember, we have rule-based intelligence as well, which is very deterministic. And then we have a probabilistic approach, which is machine learning. So while AI is not ML, it's rule-based and machine learning. Machine learning is also not AI. It's part of AI. Now, I'd like to take that a step further and level set on some other definitions as well. Machine learning, up until very, very recently, and I mean 2, 3, 4 years ago, theories existed and education existed and academia was very, very deep into deep learning. But from a business perspective, all that happened was shallow learning when it came to machine learning algorithms. So shallow learning is essentially where you have an algorithm, a model, essentially an equation that represents real life. And essentially all that does is it uses that equation in a new scenario to determine an outcome, a probabilistic outcome. So something as simple like in our human brain, something as simple as, should I cross the street? Should I cross the street to us is a machine learning issue, except that machine learning algorithm is computed within our brains. And what are some of the things that you look at when you look at making a decision like that? You look at how wide the road is, if the light is in your favor, is the road slippery? There's various factors that you may look at. How far is the nearest car? Is the nearest car big or is it small? Is it a bicycle? Is it a scooter? And then you take all of those in, you have an equation that you intrinsically compute in your brain, and then you say, you know what? I think I have an 80% chance of making it across the street. And if that outcome is higher than your risk threshold, well, then you cross the street. You start crossing the street. And if it's not, well, then what happens is you don't cross that street. And that's essentially how machine learning algorithms work. They try to replicate that human intelligence into a computer by feeding it all of these experiences, aka past instances of you crossing the street, for example, and then ultimately using that to make a decision and come up with a probability of you crossing the street successfully. Now, there's been some times, as I'm sure you're aware, where you kind of cut it close when you were trying to jaywalk, or maybe where you were crossing the street and the car was much closer than you thought it was, or going much faster than you thought it was. And what happens is you get across the street, but it was too close for comfort. So what happens is now that experience goes back into your brain, and you remember that the next time, and the time after that, and the time after that, and it serves as a learning experience. So what happens is the next time you go across the street after that learning experience, you're going to remember that. And the second you introduce that feedback loop into your learning, what you're doing now is you're building what's known as a deep learning algorithm in your brain. You're introducing the error and the outcome of your previous instances into your decision making again and again and again. So when you take that error and you use your error to make a better decision, and you cycle through this hundreds, if not thousands of times, what you're doing is you've built a deep learning algorithm. A shallow learning algorithm, you get across the street, doesn't matter what happens, you either made it or you didn't, and that's it. That data is no longer going to feed back into your next instance. It's done. So we have a one pass at trying to come to our outcome, or trying to predict our outcome, and that's shallow learning. And then when we have deep learning, what happens is we try to make a prediction, of course, where there's going to be some error in that prediction. And then we use that error in our second time around and our third time around to improve our predictions. And we do this over and over and over again until we can get to a solid decision. Now, naturally, what happens is, as I'm speaking through this, you understand that, well, shallow learning, actually rule-based intelligence, if this then that, I've seen computers do that in nanoseconds, okay? Shallow learning, well, that's a little more complex. I could see a computer doing that. Maybe, it would need to read millions and millions of records. It would need to create a modeling equation. It would need to take a new prediction and then or a new scenario and then make a prediction on that new scenario. I could see that taking maybe 5 minutes or so. But what happens when you take that 5 minutes and now you make a prediction, there's an error in the prediction, you feed that error back in, and you do this 1,000 times? Well, you're looking at something that's going to take 6, 7, 8 days, right? In a normal computing world, and if we were to run a simple deep learning algorithm on our laptops, we're looking at something that might take 2, 3, 4, depending on the power of our laptops, takes 2, 3, 4, 5 days. And that is not necessarily valuable when we're looking for decisions to make quickly, because our competitors are putting out new pricing, or our competitors are doing something else. So it's very, very important that we understand that as the computing power and the general cost of storage and computing power decrease, and as computing power increases, we're going to be able to do deep learning much, much, much faster. And cloud will enable us to do that, and new technologies and how we compute, like GPUs and so on and so forth, will help us do that. But ultimately, this is still a relatively new field, and ultimately it will grow into the dominant field in artificial intelligence, but just not quite yet, just because of the availability. Now, that's not to say that we don't have virtual machines or computing power on cloud that gets us 1 terabyte of RAM or 100 vCPUs, virtual CPUs. Of course, we have that. But there's a very, very high cost component to that might not necessarily make the ROI of doing a deep learning algorithm make sense. So while deep learning, the science exists, the applications exists, the ROI might not just be there yet. So we're at a point where shallow learning is dominant in an organization, but in the next 2 to 3 to 5 years, we're going to be moving in a world that is probably dominated by deep learning. So now that we have all of these rules kind of outlined, let's talk about what is really happening within an organization when it comes to machine learning. And what are some of the experiences that I've seen when it comes to that? The first time we saw machine learning appear on the Gartner hype cycle was in 2017, and it split from deep learning. And they were both really, really high. They were at the peak of inflated expectations, which means that there was a lot of talk and there was a lot of hype and there was a lot of adoption coming up to it. But ultimately, when it got there in 2017, what happened after? Well, after, obviously, we fall in the trough of disillusionment. So we fall into this space where there was a lot of inflated expectations and it didn't just deliver. And that happened over the course of the next, X amount of years, especially in the United States, and not as much so in Canada. But we're starting to see that influence from the United States coming back into Canada as well. We started to see that a lot of people started to lose hope in machine learning. But we're coming now at a point where we're reaching the slope of enlightenment, this plateau of productivity, where we're reaching that point where we know what ML can do, we know what it can't do, right? We talked about some of those use cases where if we're doing a lot of shallow learning, we know we can do it. We know we can do it well, and we know we can do it in a way that is cost effective and has an ROI that makes sense. And we also know that some of these other things are much more complicated when we're looking at deep learning things, when we're looking at, metrics that are not really important to an organization, but we have to use some deep learning technologies around it. We know that that's going to not make sense. So we know now, we know better. And because of that, we're now starting to hit this plateau of productivity where we know exactly what we need to do with both machine learning and deep learning, essentially. So what caused all that? I want to set the context correctly to make sure that we know what the issues were that caused this lack of confidence in ML around 2018, 2019, and early 2020. Well, it was the lack of understanding. So machine learning is a very, very complicated topic. We're talking about concepts in statistical analysis. We're talking about concepts in linear algebra. In some cases, we're talking about concepts in calculus. And these are not things that are very intuitive to people, especially when we're dealing with things that are a higher order. So, things that you learn in second year algebra or second year or third year differential equations. These are not things that a lot of people have an intuitive understanding in. And so what happens is you start to get that pushback where I need to understand it before I can invest in it. And the thing is that lack of understanding wasn't really converting into the right investment. And if those two don't kind of coincide, then you see a low investment with an expectation of a high return, and that sets the stage for a very, very bad scenario. The second thing was there was a lack of demonstrable value. And when I say value, I want to bring it back to the ROI. When you spend a lot of money, and keeping in mind that machine learning algorithms, they're compute heavy, they're storage heavy, which means that you're going to be dropping money into this pool of computing resources. But that pool not only that decision that you use that pool for, not only has to make up for what you're paying in those computing resources, but ultimately has to also drive some business value as well. It ultimately needs to drive some sort of decision that can help you gain an extra customer, make an extra sale, or increase your revenue, lower your costs of some sort. And what was happening was these costs were off balance. And what was happening was at the end of the day, the ROI just didn't make enough sense. There were high development times. In other words, folks were spending a little too much time, partially because they needed to custom build algorithms. They needed to set some of that foundation that would help ultimately put us in position of where we are today. So it was a little early. The costs were a little too high. The ROI wasn't fully there, and that sometimes caused some lack of confidence. And then finally, there was a lack of talent. I have been personally involved in trying to educate and train, and personally involved in the community to hopefully have more people join the community of data scientists, data engineers, so that we can become a broader community. I've spent time teaching. I've spent time delivering webinars. I've spent time in seminars. And ultimately, what that's done, along with some of my peers and my colleagues, we've actually augmented the talent pool. So now there's a lot more people doing data science and data engineering, but 2017, that was a different story. 2018, that was a different story. You were only looking at folks who were in heavily focused STEM fields, so specifically statistics, linear algebra, looking at engineering. From now having going from that base to now where we have folks who may not necessarily have had a STEM background at all, but are focusing on building data pipelines and data and algorithms for machine learning. So those three things kind of cause this lack of confidence in machine learning, this kind of lack of confidence in the value of machine learning. But ultimately, that's behind us. That's the past. And now we're going into this plateau of productivity that will ultimately, that is now starting to kind of drive some of that value. We've seen, understanding come up. We've seen costs, development time and costs go down. ROIs start to be more focused, and we've seen the talent pool grow bigger. So some of these challenges that we've seen have now started to kind of dissipate, and now now we're moving into a position where now is the right time to make those investments into AI. Moving on to the next slide. Now that we understand what AI and machine learning is and deep learning is, well, I want to talk about how is that different than analytics. In a lot of cases, the two are very well intertwined. And in many cases, we have to kind of do that untangling. We have to figure out how is analytics any different than artificial intelligence. And there's a few buzzwords in this space that I'd like to demystify if possible. For one, analytics is not just data science, and artificial intelligence is not just data science, right? These are two. Data science is a term that encapsulates anything that a business may do with data, whether it be data engineering, whether it be data science, whether it be ultimately, I've seen it used as someone who is cataloging, tagging data assets. So I'd like to possibly, if I could, never use the term data science again, but unfortunately, we're in a space where we have to use that. But I do like to make a distinction between analytics and artificial intelligence. And ultimately, what's happening here in the background is both our business processes that will ultimately get us a good, strong, effective business decision. The only difference is the process in getting there. And I'm going to focus on analytics for a second, and then I'm going to show you guys how it differs in artificial intelligence. So when it comes to analytics, as you all know, data is collected, whether it be from your source systems, it's brought into maybe a centralized data repository, like a data lake or something of the sort. And then ultimately what happens is there's some transformation, some data engineering that goes on in there. And ultimately you display some of that data in a visualization tool. And I'd like to wrap that all up and just say that's my analytics platform. When I'm doing my ingestion, my transformation, my visualization, let's call that an analytics platform. What is the purpose of the analytics platform? Well, what happens is a human ultimately goes into a platform, looks at the context, looks at all the insights, creates the story in their head, and then from that story, a decision is made. Now, whether it's how many of these supplies do I need to order, or how many customers can I tackle, or in different various use cases. But ultimately, there has to be some human intuition that goes into that. There has to be some human layer that is attached to that analytics platform that ultimately says, yes, there's a decision to be made here. I'm going to make that decision. And then ultimately that decision is going to be part of my business process that triggers some form of downstream task in that business process. So for example, I'm going to use my analytics and say, well, my customer would require 35 of these boxes next week. So now I'm going to go into my supply system. I'm going to type in 35, press enter, and ultimately down goes that business process. It goes downstream to the warehouse, shipping, and so on and so forth. So the human is very, very involved in that business process where we have some intake data, some source data. We have it all kind of brought together into an analytics platform. Then a human applies some intuition, some perspective, and makes a decision. And that decision triggers some downstream business process. And that's analytics. And it's really, really good. And it's been really effective for years and if not decades of making good decisions. On the other hand, what we're seeing now is that artificial intelligence and AI, and specifically machine learning, can kind of replicate that process without that human perspective, but not always. And we're going to talk about why not always in a second. But we can take that process of having some data upstream, having some decision-making ability, and then ultimately passing a decision downstream so that downstream business processes can happen. And that's essentially what happens in an AI process. In an AI process, we have data from some different source systems, whether it be our CRM, ERPs, warehouse management systems. All of that data is brought in, transformed, ingested into what I'm going to call a modeling platform, whether it be open source, whether it be some sort of specified vendor, a modeling platform that essentially that essentially takes that data, trains that data, tests that data, validates it, builds the model, and effectively lets you make a decision on it. That's a modeling platform. Ultimately, then what happens is that serves as kind of the virtual data store, that virtual brain, and then decision generation platforms or decision generation tools. Very, very simple. All they do is they ask this modeling platform, the modeling brain, for a prediction. They take that prediction and make it part of the downstream business process. And we can effectively automate the entire stream from the data ingestion, transformation, feature engineering, train, test, validate, all the way to predict, obviously some scoring in there, so all the way to predict, and then that prediction going downstream in our business process. So it's essentially if we were to take a swim lanes, and I'm going to step back and become a management consultant for a minute, but if we were to take our swim lanes, anytime we see those rhombic shapes where there's a business decision to be made, all of those can now be replaced by either an analytics process or an AI process. And they're both different, but ultimately they get you to the same place, which is making a decision that enables a downstream business process to continue. Now, I like to call this analytics versus AI, but ultimately, we know that in today's world, they're just better together. And we can't escape, in today's world, we can't escape the need for both. And there's reasons why. But I'd like to touch on those reasons in just a second. I think that human-based decisions, the ones that we make because we have strong analytics platforms, that we have trustworthy analytics platforms and trustworthy insights that we can apply a human rationale to and ultimately make a decision. But also because we can also take some of those simpler decisions, some of those mundane decisions, and automate those decisions using some simple algorithms. And those algorithms can then help make decisions along the way as well. So on one hand, we can either use analytics and some sort of very light touch machine learning to augment that analytics. But at the same time, we can also use automated decisions in which humans are not involved at all. And if we bring these two together, we can actually have effective decision-making capabilities within the business. Now, there's a reason why we still need human-based decisions. And there's a reason why we still need analytics. Maturity of data in many organizations is becoming a priority, but it's not there yet. There's a lot of things that are not collected, that are not stored, that are not organized correctly. There's a lot of business rules that businesses still need to figure out. There's a lot of transformation that still needs to happen. And ultimately, what that leads to is this need for a human perspective. As we talked about in the previous slide, there's always going to be that human intuition and human perspective on top of that helps make those business decisions. For example, if my sales rep was out playing golf with our client last week, and all of a sudden I'm seeing a spike in these box sales, well, if my sales rep playing golf was a feature of my model, then yeah, maybe my model would perform much better because it now has that piece of information. But think of it this way: if an analyst didn't know that sales rep went out to play golf with one of the customers, would they know to spike up the sales for next week? Well, they probably wouldn't. So what happens is, yes, there's data and signal everywhere, and some of it is not really captured in our source systems, but it is captured in our human systems. And that's why, for the time being, until we capture all of these variables, all of these features, and the maturity of that general data function within the business increases, we will still need to apply human intuition and human perspective on top of that. On the other hand, there's now a bigger and broader use for automated decisions because of investments that we have made into collecting data correctly, into making sure that it's managed correctly, into making sure that's cataloged, stored correctly, quality is good, and we're doing all of those things. There's a lot of organizations who have that solid foundation, and because of that, they're now able to convert some of those business decisions from a human-based decision to an automated decision. And when you do that, there's also value in doing that, not just in reducing costs and allowing for our human-based intuition to focus on more complex decision, but also at the same time in that automation and that ability to react faster. So at the end of the day, for the foreseeable future, I still do believe that these two are better together, and that we're going to be using human-based decisions and applying that human perspective and that human intuition, but at the same time, our automated decisions to make good, effective, and strong business decisions. So that's guiding principle number one. Guiding principle number two, I touched on a little earlier, but I'd like to kind of bring that up again, is that you need a solid foundation. And I was talking about data in its collection, storage, organization, cataloging as the foundation, but all of that cannot happen. It cannot happen without an even stronger foundation underneath. And there's some critical supporting capabilities, as I like to call them, that need to be in place, that need to be thought about, that need to be strategized for our analytics and our machine learning processes to be correct. And essentially, what they are, starting from the top, are information management. So not all data, not all information is data. We can talk about that later, but mostly governments do have some requirement to store emails, to store various things that may not necessarily need analysis, but they need them for their archival and retention purposes because that's the law and the regulation. So there has to be some form of information management capability within governments, within various specific niche businesses. But all that is now founded on a solid investment of technology, whether it's infrastructure and platforms for cloud, but also all the on-premise infrastructure and platforms that we need as well. So that includes things like networking, servers, storage, all of these other capabilities that enable us to be able to deliver some sort of software, deliver some sort of tech capabilities within the organization. And none of that would be available if it wasn't for these digital investments. So if we are in automated data collection, we're looking at things like IoT, but we're also looking at things like robots. A lot of robots on a manufacturing line, for example, they create and generate data, but they also generate decisions. So those are decisions that we want to capture. Those are the right investments that we want to digitize. Essentially, we want to translate analog signals and manual handwriting and things of that nature into digital signals. So there has to be a solid investment in that. Now, if there isn't a solid investment, then you can still use data for analytics and machine learning, but you have to understand where all the pitfalls are because of lacks of investment in technology, in digitization, in information management in some specific cases, but also at the same time in data as well. So trust in your machine learning outputs is almost as equivalent as trust in your analytics outputs, in that if the right investments aren't made in data, in information management, in technology, in digital capture, signal capture, then we're looking at holes that may be too big to overcome, no matter how good the algorithm is, no matter how good the process is, no matter how good our analytics platform is. So we always have to put a little asterisk whenever it comes to sending out our predictions, our outputs, and ultimately our decisions. We have to understand all those pitfalls. That is guiding principle number 2. It helps build trust. It helps build an understanding within the business of what are potential pitfalls and what are potential places where these decisions are really good. A really nice thing to do if you're building a model is to send along a documentation package and just describe at a very, very high level where did the model perform well and where did the model not perform so well. And the same thing with analytics. Whenever we push out a dashboard or a report, there should be notes around, we don't really effectively capture this, or we sometimes don't capture this, and there's data quality issues here. All that does is it helps us build trust. So we want to make sure that we use analytics and AI together because they're better together. But at the end of the day, we want to make sure that if the supporting capabilities are not there, then we want to build trust by ultimately documenting and communicating exactly where the potential pitfalls may be. Now, my third guiding principle, and I will keep it to three, is where do we start? Picking the starting point is always the toughest challenge. And I know that a lot of you have seen value versus investment graphs, and essentially at the end of the day, this is nothing really new. This is really not much when it comes to these are things that happen in business 101, as I'd like to put it. But sometimes we forget that business 101 has to drive the conversation when it comes to AI as well. And I've been guilty as a data scientist or as a data ML engineer. I've been guilty of sometimes forgetting about this, and I know that a lot of individuals have also been guilty of picking the wrong starting point. But just to level set, we want to pick that starting point that's on that top left box, the high value, low investment. So in other words, what does it mean to have a high value solution? Well, a high value solution is something that has visibility, something that is required by multiple functions of the business, not just one. And we want something that is foundational to the business that can ultimately drive a lot of downstream business processes. And there's a lot of use cases in this. We'll talk about 5 specific ones just in just a minute. But ultimately, high value is visibility. We want usability, and we want it to drive a lot of downstream processes. So what makes it low investment on the other hand? Well, I talked about a little earlier about how at the very, very beginning in 2017, there was a lot of custom algorithms that needed to be built. Well, over the last 5 years, what happens is the early adopters have built packages and prepackaged solutions that we can actually use to feed in our data and get really, really good outputs from it, really, really good products out of it. And why that is because these auto ML algorithms, what they're doing is they're essentially tailored to some specific use cases, and all you want to do is you want to feed them to the data. They run through the entire process, and then they ultimately spit out some output. But you have to know where auto ML is good and where auto ML is not good, and that's what we're going to be talking about in just a minute. So focus on those high value, low investment solutions. And those are the ones that are going to start that buy-in process when it comes to machine learning in the organization. So high value, lots of visibility, lots of usability, and lots of downstream processes. Low investment, you want AutoML solutions that you can use pre-built algorithms to get some value out of rather than custom building those solutions yourself. Try to avoid low value, high investment solutions, of course, but I've seen a lot of folks try to, we're going to do deep learning and neural network to solve a very, very simple problem that a simpler algorithm might give you the same ROI on. So it's not always about investment time and development, and it's not about getting 87% versus 88% accuracy. It's about the ROI at the end. Once you sum up all the costs and all the profits and all the money brought in, is that the ROI at the end makes sense, not just because it's a lower cost in development, but because it brings you more money as well. So try to avoid those high investment, low value. And then just some caution around some high value, high investment, and low value, low investment solutions. So low value, low investment. If there's not a lot of visibility, there's not a lot of downstream processes on it, this is more of a niche algorithm that you can build that can help, maybe 1 or 2 departments or functions within a business, but not ultimately the entire business. So it may be a good start if you're shy about it, but ultimately, if you want to jump right in, you want to make those high value, low investment solutions realistic. And ultimately, I just like to end with what are the five use cases that I've been talking about? Well, the five use cases in which AutoML performs really, really well. Remember, this is giving you that high value, low investment solution. Well, there's five key ones. There's predictive forecasting. So taking a KPI like sales, like quantity sold, like, for example, revenue generated, and predicting that X number of periods forward. There's a lot of good tools. One even comes from Facebook called Facebook Profit that helps us do that. Very, 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 very good. And you just plug and play, and everything comes out as required. There's good sample use case for that. Like I said, revenue generation forecast, sales forecast, things like that. Quantity sold, anything that you need to predict out into the future. We have outlier identification use cases. So we're looking at things where anomalies and anomalous behavior become a factor. So looking at things like fraud detection. Fraud detection in insurances is ultimately a very valuable use case. But it doesn't only have to stay within insurance. It can also move over to any other business that is trying to determine any anomalous behavior. So for example, if you promo a specific item and you're not seeing the sales from it, then that's something that's anomalous. And you can use you can use an outlier identification algorithm to determine, well, what is so anomalous about this? Why am I not getting the conversions that I want there? But ultimately, very strong AutoML algorithms that help with that. There's also some clustering algorithms. Clustering algorithms are specifically useful when it comes to customer segmentation. There's a lot of marketing agencies that ultimately have created their framework of customer segments in Canada. Some that have 52 various customers in Canada that try to take the general population of Canada and try to create segments. And it may work, but what works best is looking at your own data and determining what are the customer segments in my business that are relevant to my business, instead of trying to take those customers and fit them into 52 generic customer segments. And when you do that, you unlock more insights into who your customers are, rather than specifically who these generic 52 groups are. There's also computer vision. So computer vision quality control is one of the key use cases. There's a lot of good AutoML algorithms that try to do that try to say, here's a pipeline, for example. There's some rust here. You can have in oil fields, you can have a drone fly through, take pictures of every centimeter of that pipeline. And if there's some rust, or if there's a crack, or there's something of that sort, we have computer vision algorithms that'll tell you there's some rust here, there's a crack here, there's an animal here, and it's able to identify those objects and then tell you, hey, something is wrong here. But at the same time, on our manufacturing line, we also have quality control processes where we need to take a picture. Maybe the length of something we produced isn't the right length, or the width isn't the right width, and computer vision algorithms can help with that. And finally, there's natural language processing, where we're taking some speech. We can either convert it to text and try to understand the theme, the context, try to understand what is going on, and then ultimately use that to build a chatbot so that our customers can have an initial touch point where they can get some of their questions answered, and then ultimately, if not, then get redirected to a human. But try to take care of those triage use cases, essentially, that can be solved really, really quickly without a phone call. And these five are really, really strong because, like I said, there's AutoML algorithms on there. They're plug and play algorithms, as we call them, that can already help you determine exactly what it is that you need. It gives you that high value, and it gives you that low investment right from the start, and it gets you going right from the start there. So these are five use cases I would personally note, and I would pick one of these five as a very, very strong starting point. There's other use cases in which machine learning can help. Optimization is another big one, but The problem is that the science is not at a place yet where we have these AutoML algorithms that make it, for example, a low investment solution. So we want to avoid optimization if we possibly can. And finally, how do you get started? I'd like to wrap everything up together. Well, I like to say it's as easy as 1, 2, 3. So just wrapping everything up together. Pick a business solution for automated decisions that falls within the 5 use cases to start. We talked about the 5. If you pick something there, you're guaranteed to get low investment, high value. Make sure you collect the requirements properly. Make sure you're involving all the business process owners in that collection. Make sure that everybody feels like they're a part of it. Step 2, identify a proper platform to help deliver the solution. So we talked about some AutoML platforms. There's many that are open source. We prefer to work with 2. One is Alteryx, that allows you to blend some of those data engineering and those data science algorithms together. And then the second one is Data Robot. Data Robot is ultimately one of those platforms that does it all for you. Databricks is another one that allows us to do a lot of the data engineering and the model modeling, but from a custom perspective. So that may be down the road, but we have Alteryx and Data Robot for that AutoML, and then we have Databricks for that custom machine learning component that we build. And then finally, talk to us. We have experience. I'd like to say I've delivered successful and unfortunately unsuccessful machine learning solutions. And we'd love to help you out with our lessons learned. We'd love to help you out with whatever it is that you have. There should be a box in the top left corner to a Calendly link. If you'd like, you can click on it. You get a 30-minute conversation with me. I would love to hear where you guys are in your journey, and I'd love to have anybody who wants to talk about their AI and machine learning use cases come together. So with that, I'll move it over to our questions section. I do realize that we have 2 minutes left, so if there's any questions, feel free to pop them in the Q&A box. There's 2 questions here already as you're talking industry specific. So I tried to touch on as many industries as possible. Thank you for that question. Unfortunately, it's not industry specific, but if you'd like, please reach out to me. We can talk. We'd be more than happy to share our experiences for industry specific use cases. Is it recorded for us to view later? Yes, it is recorded, and I believe we'll be sending out an email with the recording if you manage to join. And finally, when is your next session? Keep an eye out on LinkedIn. We're still planning on what the next session is. It will probably be a level down from these guiding principles. That'll be into first implementations. So please keep an eye out on that, and we'll try to make sure it's all over LinkedIn and our website, and making sure that everybody has access to it. Alrighty. Okay, and if those are all the questions, I'd like to thank you all again for coming. I appreciate you all being here. I appreciate you taking an hour out of your day to join. If you'd like to get in touch, info@newcom.com, or you can visit our website. If you'd like a 30-minute conversation, there should be a Calendly link somewhere here where you can click on, and we can have a 30-minute conversation. Thank you very much. Have a good one.